this video, we are going to cover how to calculate the empirical formula. But before we move on calculating empirical formulas, I want to remind you that the molecular formula is the actual chemical formula, while the empirical formula is the smallest ratio of the actual formula. Now, when we're calculating empirical formula, you may encounter two types of questions. The first type will provide you the mass of each element present in the compound, and the second type will provide you with the percent composition of the compound. In the first example, we're going to actually look at the first type of question where you will be given the mass of each element. When calculating the empirical formula, you are going to follow a series of steps. The first step is that you're going to need to convert the grams to moles. Then you're going to simplify the mole ratio. And finally, write the chemical formula. So let's go ahead and see these steps in action as we go over our first example. Now the problem states that you have a sample that has 0.504 grams of hydrogen and 4.00 grams of oxygen. What is the empirical formula? The first step is to do a mole conversion by converting the grams to moles using the atomic mass for each element. So you're going to convert 0.504 grams to moles, and you should obtain 0.500 moles. And for oxygen, you have 4.00 grams, and when you convert that, you have 0.250 moles. Now that we have determined the number of moles for each element, we have to determine the smallest number. And in this case, the smallest number is 0.250 moles, and that's the mole amount for oxygen. We will use this number to simplify our mole ratio. So you take, for hydrogen, 0.500 moles and divide it by the smallest number of moles, which is 0.250, and you get a ratio of 2. For oxygen, since you're using oxygen 0.250 moles, you divide it by the smallest number again, and you get 0.250 divided by 0.250, which is 1. Now that we have determined the mole ratios, 2 and 1, we can actually write the formula. The mole ratio you obtained in the last step, you can use as your subscripts for your chemical formula. In this case, hydrogen was 2 and oxygen was 1, and when we write this as a subscript in our chemical formula, you end up with H2O. So let's go ahead and do a quick recap on how we got the empirical formula. The first part, we did a conversion from gram to moles, then found the smallest number of moles to determine the mole ratio. And once we had the mole ratios, we used those numbers to be the subscripts for our chemical formula. Hopefully that was easy peasy breezy. Now that we've just saw an example of a problem where you are given a mass of each element in the compound, now let's take a look at a problem that gives you the percent composition. So now when you're calculating empirical formula from percent composition, they look exactly the same as far as the steps that you need to use in order to get the empirical formula. But there is one extra step. And this extra step is we actually assume that we have a sample of 100 grams. And so you can convert all your percentages into grams. And once you have the grams, you can go ahead and convert from grams to moles, find the mole ratio, and then write the chemical formula. So let's go ahead and apply these steps in the example. In this example, you have just sent an unknown substance to a lab a few days ago to be analyzed using a mass spectrometer. And the lab sent back the results of their analysis and found that the substance contains 36.86% nitrogen and 63.14% oxygen. What is the empirical formula of a compound? So our first step is going to convert all those percent into grams. So your 36.86% for nitrogen now becomes 36.86 grams, and for oxygen it goes from 63.14% to 63.14 grams. you've done the conversion of percent to gram, now we're going to just straight up do grams to mole conversions like we did in the last example, where you use the periodic table to find the atomic mass. And the atomic mass for nitrogen is 14.01, and the atomic mass for oxygen is 16.00. And so when we go ahead and do the mole conversion and obtain the number of moles for each atom. And you have 2.631 moles of nitrogen and 3.946 moles of oxygen. We then use the smallest number of moles, which is 2.631 in this case, and we divide each mole to obtain the mole ratio for each element. Nitrogen, since it's going to be divided by itself, is going to be 1. And for oxygen, you're going to take the 3.946 divided by 2.631, and you should get 1.5 as your mole ratio. As we did in the last example, we will now use the numbers in the mole ratio as the subscripts in our chemical formula. So let's go ahead and write it down. Our chemical formula should be NO1.5. Now, there's a slight problem with this. Atoms don't exist in fractions. We can't have a fraction of an atom, so we cannot write a subscript of 1.5. We have to have whole number subscripts just because fractions of atoms do not exist. So this is not a possibility. You can never leave it as a fraction. We have to multiply it by some type of factor in order to get it to a whole number. And so in this case, we would multiply this by a factor of 2. And if we do that, we should get a chemical formula of N2O3. This is a happy empirical formula because it is the smallest ratio and it does not have a fraction. So now you have seen examples from the two types of problems you may encounter when trying to calculate the empirical formula. I do hope that this tutorial has helped you, and thank you for watching it.